All right, so now we're going to be finding the volume by shells. And what a shell is, it's like the lining of your hydro flask. So we're finding the volume of that. And how we're going to be generating this is we're going to be taking a rectangle of thickness dx here, revolving it about the y-axis so that it spins around and makes this like insulation. So the axis for the radius of the shell, the radius if I'm spinning it around the y-axis will be x. F of x will be the height of the shell. So think of it as 2 pi radius height times thickness. All right, so this graph here is not your average graph, x minus x cubed. So the part of it that I'm interested in is between here and here. All right, so looking at the area bounded, there it is right there. And if I'm revolving it about the y-axis, this is the center. All right, so if I was to try to draw rectangles perpendicular to the axis of rotation, it would touch the same function on the top and the bottom. So that is not a good choice. So I'm not going to do that. So what I am going to do is I am going to draw rectangles perpendicular to the axis of, parallel to the axis of rotation. So if I draw them parallel to the axis of rotation, shells, the rectangles are parallel, not too hard to remember, right? So I get this shape. So I can see it's going to be dx integration. So volume is 2 pi, so it's my job to put in the radius and the height. The radius and then the height. Okay, because of the rectangles are being spun around the y-axis, x is the radius. So I literally just put x in. The height of my rectangle goes up to the function, so that's x minus x cubed. And I'm building these rectangles from x equals 0 to x equal 1. And that's it. All right, let's look at this next one. Y equal x squared plus 1. Parabola shifted up 1, y equal x, looks like this, and then I have x equal 1 and x equals 0. So this is the area bounded. So if I'm drawing rectangles parallel to the axis of rotation to build my shells, then I can see my volume will be 2 pi radius height dx integration. So again, radius is just x because of the distance from the center, which is the y-axis. And then the height of the rectangle will be the parabola, subtract off the line. And I'm going to be building rectangles from x equals 0 to x equal 1. So let me just draw this graph again so that you can see that this really is the best option to build the rectangles parallel to the axis of rotation. So here to here. So I'm spinning it around the y-axis, right? So this is center. So if I tried to draw the rectangles perpendicular to the axis of rotation, this would be the top and this would be the bottom here. But on this, I'd have the same top, but the bottom function would change. And then over here, I'd have a different top and a different bottom function. So this is a very hard way to do the rectangles. So I would not be doing washers with this one. All right, so let's go to the next one here. So now I have y equal root x and y equal x. And I'm revolving it around the y-axis. So this is center. So this area in here, so if I wanted to do shells, I want to draw parallel to the axis of rotation. So dx integration again, 2 pi, radius will be x, height will be root x minus x, top function minus bottom function, dx integration. And I think we can use our common sense and we know that between 0 and 1 is where they are intersect. All right, so let's just take a look at this again. Could I do this the other way? Could I do rectangles perpendicular to the axis of rotation? Yes, I could. They will always have the same top and the same bottom function. So that would get us into the shape of washers squared minus squared dy integration, because the thickness of my rectangle is dy. So remember, to find the outside radius, center to the outside, so that's getting us to the line, so that would be y, and the inside radius, center to the inside function, so I'd solve this for x, and that would be y squared. And we'd find the limits of integration on the y-axis, and that would still be 0 to 1.